On May 29, 2026, the State of India's Digital Economy Report released a metric that forced a recalibration of global tech hierarchies. India is now the fifth most digitalized economy on Earth. But the data reveals a steeper ascent in artificial intelligence. On the standalone AI Performance Index, India has taken the fourth position globally. That places the country ahead of established technology hubs like Germany, France, Japan, and the United Kingdom. This ranking challenges the traditional definition of technological dominance. Global standing is moving beyond the concentration of frontier research laboratories or venture capital. Instead, the data suggests that population-scale deployment and massive infrastructural integration carry equal weight to pure computing power. The 2026 evaluation expanded its scope significantly, auditing 71 nations that together represent 96% of global GDP. In the previous year, with a sample size less than half as large, India ranked 8th. Yet, against a vastly expanded and more competitive field, the country climbed 3 spots. Economists refer to this as positive rank elasticity. Improving a rank while the testing pool doubles suggests organic ecosystem maturity rather than a statistical outlier. Moving up 3 positions across 71 nations in a single year marks a significant realignment in the distribution of digital market power. This dashboard illustrates the CHIPS framework, the specific evaluation matrix designed to measure digital economy readiness across 5 pillars: connect, harness, innovate, protect, and sustain. The Innovate pillar tracks the traditional metrics of R&D investment, patent filings, and hardware compute. The United States and China dominate this vertical, a result of their legacy tech ecosystems and massive concentrations of venture capital. But looking at the harness dimension, we see a different metric. This measures the capacity of citizens, businesses, and governments to actually adopt and use digital tools at scale. The AI subindex grades countries heavily on this real-world enterprise and public service deployment. Because India possesses the world's largest pool of active AI consumers and deployers, that high volume of usage generates significant global market gravity, securing its 4th-place finish. This global data map visualizes an emerging trend. Developing nations account for 72% of all active AI users globally. Focusing on these specific borders reveals that India and China combined currently drive nearly 40%. Concurrently, the proliferation of open-source AI models lowered the barrier of entry, reducing the need for expensive, localized infrastructure to run complex applications. The historical model of technology moving from west to east is being replaced by immediate, mobile-first deployment. The mechanism processing AI at a scale of 1.4 billion people is digital public infrastructure, or DPI. This is the structural advantage separating India from Western tech environments. The foundational identity layer, seen here through the Aadhaar biometric system, provides an interoperable base that applications can instantly plug into. This unified public system operates differently than the fragmented private platform ecosystems that govern North America and Europe. The transaction volume passing through these public payment rails creates a dense data layer for training real-time predictive models. Processing billions of financial transactions securely every month requires machine learning to be built into the foundational architecture from the start. DPI acts as a vital multiplier, transforming a massive population into a structured and highly valuable data asset. This population-scale infrastructure is currently deployed in agriculture. Platforms like Kisan e-Mitra analyze soil health and predict crop yields for millions of farmers. Developers are also building Indic language models, translating complex interfaces into 22 local dialects to bridge the accessibility gap for non-English speakers. In the medical sector, regional healthcare networks utilize predictive triage models to manage patient flow and alleviate pressure on rural primary care centers. Educational technology platforms leverage language-agnostic tutoring to personalize learning across diverse demographics. Success in this market is visible through the integration of complex tech into essential public services, moving past the standard metric of corporate software licenses. Yet, a digital divide persists. 50% of rural households still lack basic internet access, representing a critical vulnerability in the infrastructure. There is also a deficit in domestic foundational research, coupled with a heavy reliance on imported hardware to train advanced models. To address this, the government launched the $1.25 billion India AI mission, specifically targeting the build-out of sovereign compute capacity and indigenous foundational models. Establishing indigenous compute grids is a necessary step if the sector wants to advance beyond application deployment and into core architectural innovation. To climb from 4th place toward the top rankings, the nation must achieve total compute sovereignty rather than relying on external infrastructure. India now occupies a specific geopolitical position. It serves as a primary bridge connecting massive developing world adoption with advanced frontier capabilities. The country is transitioning from using digital rails built in Silicon Valley to designing its own new foundational standards. This shift positions India as a primary contributor to how AI is applied and managed across the entire developing world. On May